So the topic I want to talk about is causal learning for retail marketing. I'm going to stay here with the computer because the remote is not working. So if the slides aren't changing, someone please let me know. All right. So let me start with a kind of brief setup of what I have in mind. So I'm sure everyone here has kind of either worked with or encountered retail marketing in some form. So you can think of it as a sales promotion or an ad of some kind. I think a lot of people here might have experienced running these on websites. You know, you might have certain people seeing a change in the website of some kind, or certain people getting a discount and certain people not getting a discount, right? And in cases like that, it's usually pretty easy to control who sees what. Like you can, for any given customer, you can say that this person has been exposed to a promotion of some kind and there's somebody else who has not. But I think what's more interesting is the cases where a more general version of this, right? Where you can't actually control who sees your marketing campaign. So imagine if you were to have an ad on television, right? Like you can control where it airs, you can control when it airs, but you can't always make sure that a particular person has seen it and somebody else has not seen it. So in a very general form, let's say there's two customers, A and B, and B has seen your marketing campaign and A has not. And the question we're kind of looking at here is twofold, right? Like one, what was the effect of the marketing campaign? Like, did it have any impact on the customer's behavior? Did their outcome change in some way? And I'm using outcome very loosely. We can think of it as some form of expenditure. Maybe they spend more money on your website, or maybe they take certain actions. They might register for certain subscriptions that you are trying to increase sales in, right? And customer A is a normal person who has not been exposed to this. And what we're trying to get at is, how do you value this marketing campaign? Like, was it effective and was it worth the investment that you put into it? So in terms of like, besides just the value of the campaign itself and like, was that investment worth it? There's a lot of reasons why you might want to be able to measure this very precisely, right? So usually marketing campaigns are not one-offs. You will do it once and then you might do something similar in the future. You might maybe do the exact same thing in a different region, in a different country. And at that point, like, it might be useful to understand like, how valuable was it? And in particular, what determined how valuable was it? So how much should you be spending going forward? And the final piece of it is, in the case where you can't always control who is being exposed to your marketing campaigns, is there a way to target it more effectively? Let's say I wanted to sell a very expensive television. There may be certain customers who just buy a lot of electronics and therefore have greater propensity to buy it. There may be somebody who has not bought a TV in 10 years. That person is more likely to buy it than someone who bought a TV last year, right? So how can you target these things better? So at a high level, these are the kinds of questions that I have in mind with this presentation. I will focus a lot on the first one. How do you measure the value of a marketing campaign, particularly when it's not easy to just run an experiment on a website and see the click rate increase, right? So let me go back to the setting. So what we're seeing is a customer who is exposed to a campaign and a customer who is not exposed to a campaign. And very intuitively, this is not the most useful thing to see. What you really want to see is the exact same customer with the marketing campaign and without the marketing campaign. How would they have behaved? How would their outcomes have been different? I've explained this to people with a physics background in the past, and they really like this kind of view, like many worlds, right? Like there's one reality where you have a promotion and there is an alternate universe somewhere where you don't have that promotion and therefore nobody can possibly see your marketing campaign. And this leads very obviously to the next problem. You don't see multiple realities. You can only see the one that you have. So you don't have a customer who sees the marketing campaign and also does not see the marketing campaign at the same time, at the same location, and in the same mode that you're interested in, be it your website or your app or something different. So the problem of understanding what kind of value your marketing campaign caused is really one of missing data. If you were able to somehow see what that customer would have done absent your campaign, this would be very easy. The difference between their expenditure after seeing the campaign and what they would have spent had they not seen the campaign, that is the immediate impact of your campaign. And if you add this up across all your customers, that right there is the value that you have generated over any horizon that you're interested in looking at. So this is an AI conference. I'm going to bring it back to machine learning and AI. So as I mentioned, the problem is one of missing data. And there's obviously very powerful tools that we can use to try to understand, is there a good way to extrapolate or interpolate what that missing data is? Can we predict what the outcome of a customer would have been had they not seen the marketing campaign? So the goal, estimate B's behavior and spending if they had not had exposure to the campaign that you have run. And how best to do this? There's many ways to do this. The essence of it is always constrained by two things: how much information you have available, how much information you are allowed to use. In some cases, with very precise targeting, you may not be able to, for legal reasons, to use things like a customer's location. And those kinds of features can be very powerful in predicting what a customer might do. So you want to use all available information you have to guess the outcome without the campaign. And you might also be thinking about, do I want to do this for each customer? Do I really think there's going to be a lot of difference between one customer A and one customer B? Or do I think it's more of a regional thing? Do I think that the state of New York will behave pretty much the same, but will be different from the state of Ohio, right? And that'll kind of tell you what the best strategy you have is. Some of them are more computationally expensive, some of them require more data, and some of them are less computationally expensive and require less data. So it does depend heavily on the use case. And so what I'm going to do in the next few slides is give kind of like a high-level view of some of the kinds of strategies. And we can, if I have time in the end, I'll try to go more specific. And one more thing I wanted to touch on is the idea of heterogeneous treatment effects. So this is related to what I mentioned about, do you think everyone is going to respond the same way, or do you think people are going to respond very differently? So I can tell you that one of the things that I've worked on in the past is you have customers who are very active on websites, customers who are very engaged, and you have customers who are not very engaged. And there's a huge difference generally between what kind of response you would get with a marketing campaign for the more active customers versus the less active customers. So this heterogeneity might be very important. You might be interested in targeting only people who spend a lot of money or only people who are premium subscribers in some sense. And at that point, it becomes important to frame this experiment very specifically to target the segment of customers that you are interested in. Okay, so you can't see the same customer twice. You can't see them with and without the campaign. But maybe you can do the next best thing. Maybe you can find a customer who is very, very similar to customer B, who has seen your marketing campaign. And if this customer is sufficiently similar, you can assume that whatever they did would have been what your customer B who has seen the marketing campaign would have done had they not seen the marketing campaign. So that was a bit of a mouthful, so let me go back to that one more time. If in the extreme case, if you had someone who has always taken the exact same actions as customer B, let's say they registered at the same time, they bought the exact same things, they are subscribers to the same kind of features that you are offering, and the only difference that you can find is that B saw your campaign and A did not, that's a pretty good case to make that maybe B would have behaved exactly the same way that A did, and any difference in B's behavior can now be attributed to the campaign that you have run, right? And as I'm sure a lot of the audience would be familiar, you usually don't want to do this for just one customer. You don't want to find just one other customer you're comparing your customer B to. You ideally want to find many of these people, and then you want to compare to some kind of average. That'll reduce the noise in the estimate, it'll be more precise, and it'll be more reliable. So how would you normally go about doing this? So broadly speaking, this strategy is clustering matching. Matching is the case where you would try to find, usually in some supervised way, a set of features which is very similar for customers, and then you would assume that they behave similarly, they form some kind of group, and they can be treated as being very similar in what they might do in the future. If you had sufficient historical data, you could use this to group customers on this past behavior. And once you have a group, you can think of people within that group who saw your campaign and people who did not see your campaign. The people who did not see the campaign are a good proxy for what the people who did see the campaign would do had they not seen your campaign. And then if you compare this value, that can help you measure what kind of impact the campaign specifically had. So like the first thing we talked about, clustering, matching. Clustering in particular, it has a lot of applications. There's a whole bunch of non-supervised methods and so on that you can use. What I'm talking about next is a much older technique. This actually predates machine learning algorithms coming into the mainstream. It's used quite extensively in social sciences, political science, economics. And it's a simpler idea. It's basically saying, let's say you don't have a lot of data on your customers. Let's say for some reason you haven't collected it, you can't collect it, or it's just very, very noisy, it's not precise, and you don't want to use all of the information you have. If you had a limited number of features, and if you didn't think those features were very powerful in explaining behavior, it may not be a good idea to just kind of throw black box algorithms at it. It might be better instead to use a synthetic controls approach. So what this means is I'm going to create a customer who does not exist. I'm going to use the information on customers that I do have to best guess at a hypothetical fake customer who would be very, very similar to customer B who saw my marketing campaign. But I will do this only using historical data. So the marketing campaign itself could not possibly have influenced the average customer that I've constructed. And the kinds of models here are more focused on how do you weight the features of many customers such that when I combine them, I get some customer that is very, very close to the one that I'm interested in, customer B without the campaign. And so there's the famous example of this is actually nothing to do with marketing, nothing to do with ML or AI. There was a legal change in the early 2000s around tobacco. The state of California did something different where they wanted to tax it higher than other states. And now you have the problem of, do you expect that taxation to be effective? Which, if you think about it, has some very obvious parallels with the marketing, like you're making a change and you want to see behavior. So what they did there was kind of, we use the remaining US states and we create a fake California, an average California, that is going to be what would have happened if we had not made the tobacco law change. So coming back to kind of the marketing example, once again, like once you've constructed your fake customer, you can compare the fake customer and the real customer, and that right there is the value that you might want to think about. I mentioned that we can think of the problem as being predicting missing data. And prediction is the cornerstone of machine learning, AI. Pretty much everything can be framed in some way as a problem of prediction, either historical or forward-looking. You have time series models, you have panel data models, you have non-parametric models, parametric models. There's a whole kind of set of things that you can do. So meta-learners are essentially saying, what is the best way, entirely naively, to predict customer behavior? I'm not thinking here specifically about grouping. I'm not thinking of matching. I don't in particular want to consider historical behavior of one customer versus another. I'm just asking a high-level question. What are the features that I have that can predict my customer's outcome most effectively? And can I find a model that will do that in a parsimonious, effective way and that will give me decent predictions? If I can find that kind of model, then for any customer, knowing their historical behavior, I can apply my model and say, okay, what would they have done next? And if you restrict the training data of this historical model to be in some period before you ran your campaign, you can assume that your predictions are now going to represent what would have happened had you not changed anything, had you not had any kind of marketing campaign. And now any deviation that you would see from the behavior that your model predicts, the only thing that's different between your model and reality, assuming your model is doing a good job, is that you had your campaign. You had a promotion, you had an event, and now the customer has done something different because of that event. So the deviation that you see is now attributable to that campaign, and therefore you can use that to value your campaign. So this is actually pretty much the cutting edge of where we are. So I'm speaking in very general terms, but some of you might be familiar with causal AI, causal deep learning, causal forests, things like that. These are all kinds of variations of meta-learners. Ultimately, the goal is you want to find a way to predict the customer's behavior without the campaign. And so because this is framed in very general terms, there's not too many assumptions that you really need to make here besides that your model is doing a very good job, which you can actually test. Given that it's testable, it's easy to do, it's very flexible, you can pretty much do any predictive algorithm here, and it should work reasonably well. All right. One more thing I wanted to touch on is usually you can't see customer expenditure immediately, right? Like you might have to go for some kind of proxy. Let's say I have a marketing campaign and the goal is to try to get more people to subscribe to Prime or to watch more Prime Video movies, something of that kind, right? Now, let's say I run my campaign for a 2-week period. Maybe the week after the campaign ends, absolutely nothing happens, right? Maybe 2 weeks later, I see a sudden spike in subscriptions. Maybe 1 month later, it continues to go up. 2 months later, it continues to go up, and then it kind of tapers off. And then 6 months later, for some reason, suddenly people start taking more actions. And it may not be possible to track these customers over such a long period. It may not be possible to do it effectively. And the longer you wait, the more campaigns these people are seeing. They might be exposed to other things. There might be other events. COVID-19 might come back, something like that, right? Like all kinds of things can happen that will change behavior beyond what you wanted to measure. So long-term value is not easy to get from a campaign just because it's so far in the future. And sometimes you might need to make your decisions immediately. You might want to know, do I ever want to do this campaign again? And I need to decide that within a few weeks. I can't wait a year to see whether people have actually changed their behavior. So the strategy that's usually used here is you want to quantify the relationship between the short-term immediate variables, the immediate impact that you can easily observe, and what is going to happen in the future. So then, it's called surrogate methods in causal learning. And so the idea is you have a surrogate variable that you observe in place of the one that you're actually interested in, and you would have some kind of model that will map changes in the surrogate behavior to changes in the long-term outcome. And if you can do this effectively, then all you need to do is observe the immediate lift. You have your campaign that causes some kind of lift in the surrogate variable that you are observing. And your model will now tell you, okay, if I see a lift of 5% in click rate or something of that kind, that in expectation will translate to $100 additional expenditure by that particular customer. And so now again, if you aggregate across all your customers, you have your value. I am out of time, so I will stop. Thank you very much.